In this video, we are going to talk about how to determine if a function is even or odd, and then what symmetry goes along with even and odd functions. So here I have some graphs of some examples of some even functions: quadratic, absolute value, cosine. So graphically, what makes something an even function? Graphically, we want to look that it's symmetric with respect to the y-axis. Y-axis, sorry. So if you notice, all of these have symmetry about that y-axis. So numerically, what does this mean? This means if I have a point like a comma b, that means that even if the point has a negative a, then I'm still going to have point b. So for example, if this was a and this was b, I have a symmetrical point on the other side at negative a. Algebraically, what this means is that if I substitute negative x into f, that it's just going to be equivalent to x. And this is actually going to be how we test if a function is even or odd, is we're going to substitute negative x in for x. If something is an odd function, such as a linear function, a cubic function, a sine function, graphically, what this means is that it is actually symmetric with the origin. So if you notice there's a point here, go over the origin, I'm going to have an equal point there. If I have a point here, go over the origin, I have an equal point here. If I have a point here, go over the origin, I have an equal point there. So it's symmetric with regards to the origin. You have to go over that origin. So numerically, what does this mean? This means if I have a point a comma b, that means I'm going to have point negative a, negative b in terms of symmetry. Another example would be if I have like negative a, b, a symmetrical point would be a, negative b. Algebraically, an odd function, when I substitute in negative x, is going to be equivalent to if I did negative times f of x. So this is going to be really important for identifying an odd function algebraically. So first, just by looking at a graph, let's decide if each of these are either odd, even, odd, or neither. So this first one has symmetry about the y-axis, so this one would be even. This one does not have symmetry about the y-axis or about the origin, so this would be a neither. This one has symmetry about the origin. As you can see, it's kind of a reflection over the origin, so this would be an odd function. All right, let's talk about a point. So if I have a point, negative 4, 9. If the function is even, which point would also lie on the graph? So again, we talked about with even, if I have a point AB, I'm also going to point negative AB. So if it's negative 4, 9, that means I'd also have a function of positive 4, 9. An odd function is a little bit trickier. If I have a point AB, I'm going to have opposite, opposite. So if it's an odd function and it has a point of negative 4, 9, that means it would have another point of positive 4, negative 9. All right, let's look at how to determine algebraically whether a function is even, odd, or neither. So the test we're going to use is we are going to substitute in negative x into our function. So in this first function, if I substitute in negative x for x, I'm going to have negative x squared minus 5. Well, negative x squared would just give me x squared. Those would be equivalent. So this is still equivalent to the original function. So even though I substituted negative x, I still get back to the original function. So when that happens, this is an even function. Let's try it for number 6. So I'm going to substitute in negative x. So I'm going to have negative x cubed minus 1. So I'd have positive x cubed minus 1. Now, so to be an even function, it would have to be equivalent to the original. It's not equivalent to the original. To be an odd function, it needs to be equivalent to if I multiplied it by negative g. Well, let's see. If I multiply this by a negative, I would get positive x cubed plus 1, not x cubed minus 1. So this function's actually neither even nor odd. All right, let's look at number 7. So I'm going to plug in negative x. So I'm going to get negative x to the 4th square root of 1 plus negative x squared. Well, negative x to the 4th would just be the same as x to the 4th. X to the 2nd would be the same as x to the 2nd. So this one, even though I plugged in negative x, this goes back to the original. This would be an even function. All right, so we have even, neither, even. Hopefully this one's odd. Let's see what happens. So if I plug in negative x, I'm going to have negative x squared plus 1, negative x to the 5th minus 2 negative x to the 3rd minus negative x. So on top, it's going to go back to being the same. But in the bottom, I ended up with negative x to the 5th plus 2x to the 3rd plus x. So is this equivalent to negative f of x? Well, let's see. So if I were to multiply negative 1 times x squared plus 1 over x to the 5th minus 2x cubed minus 1, or minus x, I could multiply this negative 1 to the top or the bottom. I wouldn't do both. So if I multiplied it to the top, I would get negative x squared minus 1 over the same denominator. If I multiplied it to the bottom, I'd have negative x to the 5th plus 2x cubed plus x with the same numerator. It's the same denominator, same numerator. So that actually matches what I have here. So this is an odd function.